Hi everyone. I've had a couple of students ask me about question number 9 here, I did post the solution for it, but it might not be clear exactly what it means or what you're trying to do in that solution. So I'm going to just go over that in a brief video if you want a little bit more explanation for this. Okay, so I've taken the question from quiz 3, version 3, but it's the way that you would solve it's almost the same for any of this type of question. Okay, so we've got a function f at n as equal to 3f n plus 1 plus 2 f at n plus 2, and it tells you what f at negative 1 is, and it tells you what f at negative 2 is. Okay, and it says you got to figure out f at negative 5. So let's suppose you're looking at this and you really have no idea how to do it. Like, it's confusing and you're not sure what to do. Well, you know you got to figure out f at negative 5. So what you might do, and what a lot of people did, was they said, okay, let's try and figure out what f at negative 5 is. And so that's not going to actually get you to the answer. It's not part of how you will solve it, which is why I didn't put it in here. But it might lead you to understanding what you're doing here and lead you down this path. So let's see what happens when you try and find f at negative 5. Okay, so we put negative 5 in for n, so that means we replace all values of n with negative 5. So we do that there. And so what's going to happen then is I'm going to get negative 5 plus 1, so that's going to become f at negative 4, and that's going to become negative 5 plus 2, so that's going to be f at negative 3. So a common mistake that a lot of people made here was they just did this. They just deleted the f's and then basically just said, oh, okay, negative 12 plus negative 6. So f at negative 5 is negative 18 or something like that. So you can't do that, right? You can't actually delete the f. It's not a variable. It's a function. So f at negative 4 means that you have some value of y when you sub negative 4 in to this function f. So it's kind of like if you had like f at x equals x squared, and then you wanted to find f at negative 4, you would put negative 4 into x squared. So you wouldn't get negative 4 as the answer, you would get negative 4 squared as the answer, 16, right? And that works if f at x, or f at n in this case, is x squared or n squared, but we don't know what f at n is. We don't know if it's the square root, is it some kind of reciprocal or what, right? We don't know what it is, so we can't actually do the calculation, which means we have no way of calculating f at negative 4. We don't know what it is. Sorry, we have no way of calculating f at negative 4, at least from here. So what does this tell you if you did this? Well, what it may tell you is if I want to find f at negative 5, I need to have f at negative 4, and I need to have f at negative 3. And you might notice the pattern there, right? Negative 5, negative 4, negative 3. So to get f at negative 5, I need f of the two numbers below negative 5, negative 4 and negative 3. But I don't have those. So how would I get those? Well, presumably then, f at negative 4 would require f at negative 3 and f at negative 2. And f at negative 3 would require f at negative 2 and f at negative 1. Well, now we're getting somewhere because we have those, right? They're given to you in the question. F at negative 1 is 8 and f at negative 2 is 5. So if I put negative 3 into f, then I'm going to get negative 3 plus 1 and negative 3 plus 2 over in these places. So negative 3 plus 1 is negative 2. Negative 3 plus 2 is negative 1. So now I have f at negative 3 in terms of f at negative 2 and f at negative 1. And again, I know those numbers. They're given to me in the question right there. So f at negative 2 I can replace with the number 5 because I'm told right here that f at negative 2 is equal to 5. The f at negative 1 I can replace with 8 because again I'm told right here that f at negative 1 is 8. So I replace the f with those numbers, and then I get 15 plus 16, which is 31. So now, just like I have f at negative 1 equals 8 and f at negative 2 equals 5, I now have something for f at negative 3. So you'll notice that I can use f at negative 2 and f at negative 1 to find f at negative 3. I can use f at negative 2 and f at negative 3 now to find f at negative 4. And then we just go one more step and we find f at negative 5. Okay, so f at negative 4, you sub in negative 4, and again you'll notice the descending pattern, negative 4, negative 3, negative 2, because negative 4 plus 1 is negative 3, negative 4 plus 2 is negative 2. So again, f at negative 2 I have, it's right there, it's 5. F at negative 3 we calculated it, it's there, it's 31. So we sub those numbers in. 3 times 31 is going to be 93. 2 times 5 is 10. So f at negative 4 is going to be 103. Okay, and now we do have what we need to get f at negative 5, because to get f at negative 5, we said you need f at negative 3 and you need f at negative 4. So I just did here what you saw previously. So I know that f at negative 5 is equal to 3 times f at negative 4 plus 2 times f at negative 3. And again, I have those numbers now. F at negative 3 is 31. F at negative 4 is 103. So I sub those in, and I get my value for f at negative 5. And yep, that's it. Then we're done. So that'll be this video done. Have a good one.